Diffusion, the international science radio show.
We have a bouncer on the doors of perception.
The good, the bad, the ugly.
It gets pretty exciting.
The myths, the truths.
Toxicology.
Astroseismology.
Magnetism. The dark side.
Genetically engineered potatoes.
Planetoid.
Planetoid.
I love that word.
Hello and welcome to Diffusion. Sit back and relax while we envelop your brain with weird and wonderful science. I'm Ian Woolf. On this edition, Maria Cunningham talks about using science fiction to teach science. Julian Assange is still in a maximum security prison without charge, being tortured while self-confessed bomb-making English terrorists go free. Join the 500,000 people who've signed the petition to free him at chng.it/5m2pgrnfzj.
This is a story of the future, but not the very distant future. It is a story that might have taken place the day after tomorrow.
Genetic selection and multiple universes. How do you teach these concepts? Maria Cunningham is a radio astronomer at the School of Physics at the University of New South Wales. I spoke to her by Zoom in a home in the Blue Mountains. You can occasionally hear birds in the background. I continue the conversation by asking Maria about science fiction films about universes next door with alternative histories. What does she think of the Marvel Avengers time travel and alternative histories films?
That is actually very good, and I haven't watched the Avengers yet, but it has been recommended to me. And actually, this is going to sound like a real first world problem, but I save movies up for those long plane trips in economy.
Not so many of those right now.
None of those right now. Yes.
You just have to schedule the time.
And sorry?
You have to schedule the time as if you were.
Oh, well, yes. In fact, one of the weirdest things I ever saw was that Singapore Airlines managed to sell out 2 A380s full of planes that never left the ground just for a meal and a movie. And people paid a lot more for it than in a normal economy airfare. So I think we're all missing travel. But that's right. I'm going to have to schedule the time. Yeah, that's right. Go to the supermarket and buy some TV dinners to microwave.
Something like that.
Coffee.
Yes. Well, so there's a lot of movies on time travel. I guess there's not as many with alternate histories and multiple universes yet, but it looks like they're coming up. Because it's an interesting. I mean, time travel's been done for decades and decades in the movies.
Yes.
And they've slowly come to grips with some of the logic of it, that you've got to make it make sense, and you can play with that, and that's a good thing for the story, not an imposition on the story. But alternate histories is one of those things, and it's implied by the many worlds interpretation.
It is, and it's very hard to get your head around, which I'm sure nobody is going to be surprised to hear. And I have known of it for a long time and idly think about it sometimes, but it's not something you're even as likely to think about as time travel. But I think that is just because up until now, popular culture hasn't embraced it. And that's partly, I think, because it is much harder to get your head around. I think having some scientific experiments that show that there is the instantaneous communication between two parts in the universe, as Bell's paradox shows, I think those things have gradually meant that perhaps movie producers and script writers, etc., are starting to think, hang on, we can base a good story around this. It may also be the closer relationship between university physics departments and movie producers. And that is probably bring fruitful collaborations that hopefully will make the many worlds theory more accessible to a younger generation. And of course, knowing that an idea exists is probably the first step to solving it, or showing it can't be solved. And so maybe there'll be a whole new generation of physicists that will work very, very hard on trying to show whether the many worlds interpretation can ever be tested and whether it's possible in reality, whether there's other constraints that rule it out. And I think science also goes ahead in this way as well, just imagination.
Absolutely. My understanding is that the champions of the many worlds interpretation would say that the double slit experiment is the single photon going through the two slits interferes with itself from another universe, and that's why there's an interference pattern. So they would say that is proof.
Yes. And once again, we can't disprove that it's proof. It's about as good an explanation as I've seen. Or is it may be fanciful, but I haven't seen any better explanation.
So would that mean, if they were right, would that mean that shows that our world would interact with some of these alternate worlds?
Yes, I believe so. Now, I wouldn't put too much weight on my opinion, but yes, I think that would suggest yes at some level. Now, whether it's just I was going to say microscopic, but really the nuclear particle level, the tinier than atomic level, even if it's just that up level, yes, I think it would suggest that interaction can occur and is possible. And once some little thing is possible, then maybe you can find something else. The other thing I would say is that relativity and quantum mechanics, at the moment, they don't have anything to say about each other. And unless, of course, you're doing relativistic quantum mechanics. But a theory of gravity, a generalized theory of gravity like general relativity, and the whole body of work of quantum mechanics, you sort of get the feeling that there should be some grand unified theory or gut that links them all together. And I think in the 1990s and the 2000s, people were working very, very hard on guts. I think they got bored. But then maybe I just don't have as much time to keep up with Scientific American as I used to. But no, I that's not true. I always find time to browse Scientific American or New Scientist, or of course these days my attention is usually drawn to those by something someone posts online. So I think if we were making great progress in that area, it would have filtered through even to me. Where as far as I'm concerned, cosmology starts once you leave our galaxy. I'm a very, very local girl when it comes to my astronomy.
Are there other science fiction films you think are good for teaching some concepts from physics?
Yes. Now, let me think about that. I've mentioned 2001. I've mentioned Contact. I think the movie Paradox, you've got to make sure you get the right one because there were a couple of them made, but the low budget one that has someone go back through many worlds. I think it's 2011? Another Earth is 2011. I know this because I had to look it up recently. Another Earth is 2011. Yes. And Paradox, I think it's the 2016 version. There's a completely different 2018 version, although apparently it's full of Neil Young songs, so I have to watch that too. But if you get the right version, Another Earth and Paradox, I think, can provide an introduction to the many worlds theory. Some things that are not quite physics, apart from all the many time travel movies, I think Gattaca is very good.
Oh, yes.
Yeah, I thought it was an extremely good movie, but it really does, it's quite thought-provoking when it comes to the abilities we will have with genetic engineering and those sorts of things. How should we use them? Will people become discriminated against because their parents didn't bother to make sure they were an absolutely perfect specimen? Will we breed out diversity?
But don't we actually already have that technology now? Because most of the stuff in Gattaca was about examining the embryos and discarding any that weren't totally perfect according to the doctor's idea of perfect.
Yes.
And we can do that now. And also about reading the DNA to identify people, which we can do now, and reading the DNA to predict what illnesses you might potentially have in the future, which we can do to a degree.
These things are actually now extremely possible and extremely good. I guess where you would be concerned is if, for example, someone in the health insurance industry gets their hands on this information and then uses it. My understanding is that health insurance can be refused, a private health insurance can be refused without necessarily giving a reason. But in the US, it's far more specific in that you need to be able to get your private health insurance comes along with your job, and that if you disclose some prior medical conditions, then you can't get health insurance. And so people in the US are very reluctant to get a test to see if they're likely to develop Huntington's disease, because once they have that test, they have to disclose it, and then they become uninsurable and unfortunately unemployable. So
it's amazing. It's exactly Gattaca, really.
It's exactly Gattaca, yes. And now, this was a few years ago when I was reading this, so I don't know if things in the US have changed, but there are small instances of this. So this information, these things can actually probably be very good, especially for people who do know they carry a genetic disease. My husband's family was touched very badly by Huntington's disease. So it's very real to us, and my family as well, which I think possibly means that a lot of families may have been touched by it. And so it then becomes quite a personal thing to think that someone will be discriminated against, but also it does mean now that you can work out, actually, that's a bad analogy because Huntington's is dominant recessive. So if you've got the gene, you just don't have children. It's more for things I'm thinking of like cystic fibrosis, which is a recessive thing, where if both partners carry it, you can still have children without the risk of having a baby with cystic fibrosis, which is a fairly nasty and debilitating condition. Although I will say some people with cystic fibrosis can now, with modern technology, do very well. In Australian astronomy, we have something called the Charlene Heisler Prize, which was actually in memory of Charlene Heisler, who had cystic fibrosis, but was able to do a PhD and do some really good work. And this, of course, it all comes back in if you eliminate things, what things are we eliminating that we don't know we're eliminating? If you take one person's version of the perfect human being, are we eliminating certain sorts of creative thought? Are we eliminating human experiences that you grow up with because of who you are, that mould you into the sort of person that makes you interesting and creative? And I don't think we have good answers to these things, but we need to move very carefully.
I think we do, because we don't know what traits we'll need people to have in the future anyway. Like, if assuming we were on board with the idea of planning people, which not everyone thinks that's a good idea, hasn't worked terribly well in the past. But we just don't know, because look, even you can't even plan your university degree for a job market that'll be there in 3-4 years' time, because the world's changing very quickly, and we just don't know. And we don't know about linked characteristics that might be associated nearby on the DNA of some of these things that are deemed undesirable. If you stopped anybody with myopia or presbyteria or any of those different types of eye problems from being born, that gets rid of most of the information working class.
Absolutely. No, my partner cannot see a thing without his glasses. You know, it's literally, and as he said to me, that if he was born in earlier times, he would have been classed as blind. And yet he has a very fine mind and, you know, contributes a lot to the community. But also, presumably, that myopia and having glasses from before he went to school probably also shaped his personality and all sorts of other things in ways that we don't understand. The other thing I would say is that humans' life expectancy is increasing. And the last time I saw in Australia, it's by about 7 months per year, which is really, really fast. And so
we just need a year per year.
Yes. So what are the traits that are going to be useful in older life? Are they the same as the traits that will make you discover specific relativity at the age of 27? Or I mean, there are many people who, once they retire, do incredible social community work. And so would we select against those traits if we were focused on the sort of human we wanted between the age of 15 and 30?
It's funny because that's even before genetics made eugenics a possible danger. You had all of the aristocrats in history were doing breeding exercises between all the major families where they excluded personal attraction and love in favour of consolidating power and territory.
That's right. And of course that worked out so well genetically with the haemophilia.
That's right.
Yes. But you're absolutely right.
You're listening to Ian Woolf on Diffusion Science Radio. Send emails to science@diffusionradio.com. We're brought to you across Australia on the Community Radio Network and podcast over the internet on www.diffusionradio.com.
And there was something very interesting I came across. I've been reading my way through something called the Penguin History of Europe because I also love history as well as sci-fi. And one of the things I came to was archaeological evidence after the Norman Conquest. And it was talking about the foundation myth of England, the idea that the Britons, after the Roman conquest, the Anglo-Saxons came, the culture changed completely, the people changed completely. But if you look at evidence, there is no evidence for any sort of change in people's height or anything else up until the Norman conquest. So Anglo-Saxons, it was probably just an exchange of cultures. It's certainly true that English did displace the British Gaelic, but that can happen. That can happen anywhere. People adopt a different language. This is not uncommon. But I was intrigued that after the Norman conquest, the soil size on average gets bigger. And I have not looked into why this is, but I presume the Normans must have been selectively breeding among their own kinds. I know they were given colonies in France and Dublin, of course, in Ireland was a Viking settlement. So obviously there was something going on there which made their population slightly different. But I still haven't found out what it is. But selective breeding has been going on for a long, long time in any closed community.
Well, there's also people interpreting history to say that in a way we've all been domesticated because we've had violently coercive leaders through most of history, weeding out anybody who's a troublemaker or challenging, not able to challenge enough to take over themselves. And so we're all a little bit more friendly and gentle than we otherwise might have been.
Yes, that is very interesting. There's a book I've got on my shelf to read. It's called War, What Is It Good For? Which sounds like, I sort of thought, who would write a book like that? A war is obviously a terrible thing, but it turns out through history that it was actually wars that made small villages, brought small villages under a larger leadership. It led to policing rather than violent solution of disputes within villages, the old blood feuds and that sort of thing. And so happily it concludes apparently that the Second World War was a bad war, which I was very pleased to hear, but saying that, yes, you can't separate human history from war, but it may have actually had some beneficial consequences. Not for those who did the fighting, obviously, or who died in it. But I haven't heard the one before about us all being a bit domesticated, but that makes some sense too, that sometimes instinctively we know when it's a bad idea to stick our head above the parapet.
That's right. You mentioned earlier you're teaching a course about physics for non-physicists using science fiction movies.
That's right. Well, it's a little more, that's right. It's a little more general than that. It's called Brave New World, and it's science for non-scientists. And you're right, it's very physics and astronomy heavy, but we do venture into IT and we also look at genetics and things like that. And so the movies, I'd say my standard fare, the movies change a bit from year to year, but 2001 is an important one, A Space Odyssey. Contact is a very important one. But I must actually give a shout out to one of my favourite movies of all time. It's called The Dish by our very own Working Dog. Yes, in Australia. And that was actually made with the collaboration of CSIRO's Radio Physics. about the role of the Parkes telescope in the moon landing. And so it's very lighthearted and very fun, but you learn a little bit about radio astronomy from watching the dish. So I definitely use the dish in my course for teaching a little bit about radio astronomy. But there's a few older ones which are very good. Science fiction movies don't date. And for anyone listening, if you're interested, Wired magazine has a very good list of the 100 best sci-fi movies you must see, the 100 best books to read, and I'd absolutely agree with a lot of those. And so if you do a quick Google search, and Wired's not the only one that does it, but that's just one that has taken my particular fancy, but I like Soylent Green.
Oh, yes.
Which I don't want to give the punchline away, but overpopulation's a problem.
That was Harry Harrison's Make Room, I think, originally, the novel.
I think so.
Which I've read.
I think that's right, yes. And that was an interesting solution to the problem.
It is different in the book. It's different in the book, quite different.
Oh, I must read the book, actually, because that's one of the very few where I haven't read the book. Thanks for that tip. Yeah, so I thought Soylent Green was a good one. Interestingly enough, some episodes from The Simpsons, Futurama. Yes. Some of those are quite and that's because Matt Groening, I think, did a PhD in some sort of science. I can't remember what might have been physics, but I'm not sure. No, it's funny, isn't it? I'd have to go and check, but every now and then my ears pricked up when Bart Simpson discovers a comet while he's on detention. And the school principal's very upset because he's been trying to find a comet for a long time, and then it turns out to be a comet that's going to crash into the Earth.
Of course.
Yes. Stephen Hawking appears in the episode of The Simpsons.
Yes.
And yes, Futurama has some good stuff about time travel, etc. The Big Bang Theory has a few good episodes with some good jokes about quantum mechanics and things like that. And so recent movie, I haven't seen The Martian myself, but I've heard it's very good. And once again, that's on my list of things.
It is good.
To see, yes. Yeah, so I'm falling behind a lot being earthbound, but I'm just going to have to make the time. Get those TV dinners, make the time.
I thought it was an interesting idea that amongst the multi-skilled astronomers you might send out towards Mars, when you're not planning to have a colony, that you would send a botanist.
Yes. This is the libretto effect again, I think.
Yes. I thought you could have written it so that he was a geologist who had plants as a hobby. He didn't have to be a professional botanist.
He didn't. That's right. Yes, that's a slightly odd one. Yeah. You could, because of course there's many keen gardeners.
Yes, who know lots.
Yeah. And I not that I have a lot of time for it, but I certainly enjoy gardening, and as well as gardening, of course, it's interesting when you're bushwalking, you'll get all the different lichens and things like that. So yes, that would have worked very well to have a geologist with an interest in botany. Science fiction has become a more mainstream part of our culture over the decades, and I think this is very important for the technological and scientific literacy of our civilization as a whole. I think the more people are exposed to science through fiction and good storytelling, the more interested they will become, and the more likely they are to search for the factual science around things, which is always very good when you're trying to decide whether an article you're reading or whether something you're listening to is true. Learning a bit of science helps you put your skeptical hat on, and that's very much for our betterment.
Well, Maria Cunningham, thank you very much.
Thank you very much. It's been a pleasure.
That was the third and final part of my interview with radio astronomer Maria Cunningham from the University of New South Wales, talking about science in science fiction movies. You can soon see the video of this interview and many others, such as James Hayes about odour, Ian Bryce about masks, Bonnie, Kirsten and Martin about the search for life on Mars, Sylvia Vicenzi about brain development, Dipon Sarkar about food microbiology, Liam Burt about synthetic chemistry, and Amy Edwards on the science of cuddling animals on the Diffusion YouTube channel. youtube.com/c/Diffusion Radio. Like and subscribe. And that's all from us this week on Diffusion. Are you a scientist, artist, biohacker or maker who'd like to be interviewed about your work? Would your company like to sponsor Diffusion? Send your contributions, opinions, helpful suggestions and donations to science@diffusionradio.com. That's science@diffusionradio.com. Please like the Diffusion Science Radio page on Facebook and rate the show on iTunes. Tell your friends. Follow me on Twitter @Ian Woolf. I produce Diffusion, which is broadcast around Australia to 28 stations on the Community Radio Network, including Radio Blue Mountains 89.1 FM in New South Wales, 8CCC in Alice Springs and Tennant Creek, 2MVR in Nambucca Valley, 3MBR in the Mallee Border districts of Victoria and South Australia, City Park Radio 7LTN in Launceston, Tasmania, and 2XXFM in Canberra. Diffusion is now narrowcast on Indigo FM 88 in Northeast Victoria. Diffusion is syndicated globally on the National Science Foundation's Science 360 internet radio station and also on astronomy.fm. Subscribe to the podcast on the Diffusion website, www.diffusionradio.com. That's www.diffusionradio.com. Check the website for links, photos and videos about this week's show. If you enjoyed the show, you can explore more than 1,000 previous episodes archived on diffusionradio.com, where the shows are labelled by keywords so you can focus in on the stories you want to hear. Join my patrons at patreon.com/diffusionradio. Make a donation through paypal.me/IanWolf. Support Diffusion by buying from the affiliate links at diffusionradio.com/support. I'm Ian Woolf. Join us inside your audio device of choice for more science wondering next week on Diffusion Science Radio.
Science is fun. It helps you to learn, to know, and to appreciate. When you study science, you may go on field trips. You discover the marvelous interrelationships between all living things. You learn to read the history of the Earth as it is written in rocks and fossils. You find out what makes things tick, everything from a molecule to a living organism. In the study of science is found the most useful and satisfying knowledge of man. Knowledge of his physical world, its past, its present, and its future. And in your moments of relaxation, now and in the years to come, you will find the study of science leading you into fascinating pursuits. Photography, collecting. Why study science? Study science because you will find in the study of science a richer, more rewarding life.